Hello, this is part 3 of Lab 2, and or part C, or however you want to call this thing, part 3 with it. I am on, I'm going to do some problems with you. And number 6, this is number 6 on page 107 in the 7th edition with this thing. So what I'm going to do is I'm going to just open up a paint brush and kind of use it as a board with it, and just review with you some of the stuff I'll be review for you before we get too far with this down the end. If you recall, in our lecture notes, there is an order sequence that you would actually do to when you have a sequence of operators. When I grew up, there used to be an acronym I would remember. If you remember, order of precedence for the operators: please, excuse, my, dear, Aunt, Sally. And each one of these acronyms stands for the parentheses, exponential, multiplication, division, addition, and subtraction. So if you have a whole bunch of operators like this, you follow this order sequence. However, when you have just the multiplication and division, or just the addition and subtraction, what do you have to follow? It's called the associative rule, which goes from left to right. Take, for example, 6a. You have 28, subtract 3 plus 6 equal what? Well, because subtraction and plus addition are equivalent to, so you do it from left to right. So 28 subtract 3 is 5, plus 6, that will give you 31. Okay. Part B asks you, for example, 6 divided into 5. What does that equal? Well, this is you got to be very careful with this thing, because this goes to what I'm talking about is the precision. And remember my lecture notes about what is, if you took 5, I'm going to do the math on the side here. 5 divided by 6 goes into 1. Oops, 5 I meant to say. 5, and you subtract 1, and if you want, you can add another 0 here, right? So you have to add a decimal here. So if you add a 0 here, this becomes what? 2. So this is 1.2 with it. But, the answer 1.2, however, whatever this thing that you set, if this is an int, if the data type, if I set int is equal to x, this x that I just created to store in here, it's going to drop off this decimal part right here. So x becomes just 1. If the answer, well, if I want to store in x, if I did a float or a double, let's say if this is a double, okay, x, then it's going to allow me to take that 1.2. It will take this decimal part. The reason is this is a 4-byte, this is an 8-byte, much higher precision rounding off when you actually do your calculation. Okay, so that's why what you're going to see is very important how things actually takes place, and with how you assign your memory with it as well. See if I can clear this thing. Save it. Okay, let's take another one, for example, C. Okay, it tells you is 3 times 6 divided by 2, subtract that from 15. What does that equal? Well, if you look at C in this right here, what do you do first? Multiplication, division. Here's this part first, right? So this is multiply, right? So you do this from left to right, right? So what happens here? This is multiply, division. You do this from left to right for me. So this is what? 18 divided into 2 equals what? 9. Subtract that from 15. That will give you a negative 6. Alright, so that's part C. Remember now. Alright, D. Look at this. Okay, I'm running out of time. Sorry, let me stop.